Hi everyone, welcome to the webinar of World Broadband Association. My name is Samir Malik. I'm a senior principal analyst and a lead consultant working in Omdia at Informatech, and I'm to be moderating this whole session of webinar on driving the future, understanding the landscape of the cloud network convergence. So I will be presenting first about the whole scenario that why actually we wrote this white paper and then why we are arranging this webinar and then share our thoughts on this one. And then I have a speakers with me that they can share their framework as well. So before we can start, some housekeeping point that if you have any, please feel free to use the question widget on the right side of your screen and then pop up all the questions. We're happy to answer that one. You also have on demand of this webinar and all the resources like this, the slide deck and the white paper that we wrote on the cloud network convergence. You can download from this directly from the link or after the session as well. So it's easily accessible. And also requested if you have your mobile microphones are not muted, please mute it. Then we have avoid all the echo and all the disturbance during the webinar. So starting then, again, I already presented myself. I'm a Samir Malik, based in Australia, senior principal analyst for Omdia, taking care for IP network routing and switching. And I'm moderating this session. Today I have a very, I can say, the seasoned industrialist and the technologist with me together with speaking in this session. I have Mr. Chen Chung Hua. He's a senior network engineer based in Shanghai, working for China Telecom. And he's the main contributor with me together in the white paper, talking about the cloud network convergence, what are the benefits, how the network infrastructure should be, and a telecom perspective. The second is another very seasoned speaker from Egypt, from Telecom Egypt, Majid Tawfiq. He is Access Planning Director, and he's going to talk about how we can design the access network in the cloud network convergence. Last but not the least, we have Industrial Development Manager, Mr. Eldo Artigani. He is based in Italy, and he is a very active contributor for different standards, including the ETSI, and working at the moment in Huawei as an Industrial Development Manager for Datacom industry. So thank you, everyone. Thanks, Eldo, Chen, Majid, for joining me today on this webinar, and I'm happy to listen to your thoughts about the cloud network convergence. So the overall agenda or the arrangement is like this. I'm going to present first, and then I can advise and request all the other speakers to talk briefly about the cloud network convergence and their experiences in service providers. That's very important. And then at the end of the session, I'm going to arrange the panel discussion where I can ask the question to all the speakers, and then we can do the more discussion on the cloud network convergence rather than just the presenting on topic. And at the same time, if you have any questions, we are happy to answer that question as well. So let me start my session first. I'm covering three pages on the slides. First is that the first question comes in the mind that why cloud network convergence is imperative, why it is imperative for success. So we already know that digitalization is everywhere now. As you remember, the power grid accelerated the industrial revolution a couple of years back. Similarly, the cloudification has actually accelerated the digitalization. So when the cloudification accelerated the digitalization, it means that most of the enterprises moving their IT resources or their vision of moving towards the clouds is getting fast and fast. So considering this requirement plus AI on the top, where everybody is talking about the AI, 5G, now we're moving to 5G advanced, we're talking about the cloud computing, supercomputing. So demands are actually moving more fast, right? And then second is about the communication service providers are no more only the connectivity service providers. In my understanding, as being the analyst in the industry, I always talk about that they are more on digital service providers. They have to compete with the cloud providers. So competing with the cloud providers, what are the attractions for the enterprise and verticals in giving the service offerings or the one click to the multi-cloud interconnections, because B2B is the hot industry. Then another reason I believe is that the smart industrial digitalization. You already heard about the industrial metaverse. We have already heard about the industrial Internet of Things, where they want all the verticals, big enterprise want to manufacturing process and factory automation. So in considering that big requirement, the big question is, service providers are ready to cater their requirements of industrial metaverse? Yes or no? That's the biggest question. So when we ask most of the service providers, the answer is that service providers network are not that efficient at the moment that can cater the industrial metaverse for next 5 or 6 years, or the consumer broadband connectivity for the home broadband virtual cloud and other features as well. So that's one thing. Another is about the telco cloud and IT convergence is going on is another trend. So the growing trend of the broadband, higher throughput, latencies, demand for the deterministic network, cloud and telco convergence, smart, or you can call it smart industrialization, either on the enterprise, manufacturing units, verticals, or the cloud in the home. These are the compelling reasons that the cloud network convergence is required, where we need a one unified cloud platform that can glue my underlay network, either is IP or optical. So that's the overall the storyboard that actually compels us to write this very detailed deep dive technology white paper. So if I go to my next slide, what are the notable benefits of cloud network convergence? People always come and ask us that what are the benefits? Okay, we agree with with your reasoning, compelling reasons, but what are the benefits? So these are the list of benefits. Number one is that intelligent, reliable, secure, always on network connectivity. And I can add on top of it is not only the network connectivity, but it should be a intelligent IP plus optical network connectivity that for one unified cloud. So that's very important. We talk about connectivity. We always talk about connecting the unconnected world for many years, but the intelligent connectivity, where traffic rerouting, traffic engineering, smart traffic engineering, the network visualization through digital mapping is always missing. So that's the beauty of cloud network convergence, that actually helps you find out that how we can do the intelligent network connectivity. On top of it, that how it can helps the enterprise sectors for one click of starting connecting multi-cloud and generate more revenue. So I personally believe the B2B or business to business or B2B to C is the main uh, application area or the scenarios where service provider can leverage their network resources to build more revenue out of it, getting more higher return on investments. So we need AI enabled ultra broadband intelligent network connectivity, not only simple connectivity. And this what network cloud or cloud network convergence tells in this is storyboard. So this is some of the features. I'm not going in on every detail of every point, but I just try to uh, summarize that what are the notable benefits, that because people ask us, we already have network, then what is the rocket science of cloud network convergence? So these are the notable benefits. And if you see on the left side, as part of the World Broadband Association, we already launched this white paper. This is the main front of the main cover of the white paper. If you go to the next page, this is the white paper on this webinar. You can free to download that one. Is a very deep dive. I was the main writer on that one, and I just put the heading like driving the future, means how we can drive the future of digitalization, especially for enterprise and the consumer broadband, and then understand the landscape of the cloud network convergence. That's very important. And it's not only the Omdia as a key writer. We have a participants like Nokia, China Telecom, China Unicom. We have Ookla on board. I mean, it's a list of contributors there. You have a Swisscom, OpenReach, Telecom, Huawei. We have Expo. I'm sorry if I can miss any one of name of the participating members, but this is a contribution from everyone. And then we all endorse the concept of the cloud network convergence. And I surely I'm very confident that once you download, you will really like to understand that how we can design the underlay IP that is called datacom plus the optical network, not only the WDM or the DWDM, plus also the last mile access GPON, 10G GPON or XGS-PON network that can give underlay network platform to one unified cloud for digital mapping or network visualization, and empower their enterprises for one click to multi-cloud interconnections. So that's the overall summary for my side as an analyst. we're talking about the white paper that we're launching today on this reputable webinar of the World Broadband Association. So after my session, I would like to invite my old friend, my old colleague Chen Chung Hua. He is a senior network engineer from China Telecom based in Shanghai, and much of his experience in life in R&D for developing different solutions. So he's going to talk about from China Telecom perspective that what China Telecom understanding for cloud network convergence, why they are talking a lot in industry forums like standard bodies in keynote speeches that why cloud network convergence is a way forward. So I would request invite Chen Chunghua to present his part of the presentation. Over to Chen Chunghua.
Okay, thanks, Sammy. Hello, everyone. My name is Chen Zhonghua from China Telecom. So I will directly enter my slide. So today I would like to share with you some of China Telecom's views on cloud and network convergence. In recent years, with the development of many new technologies such as cloud, network function virtualization, software-defined network, SIV6, and so on, we find it still difficult to meet the requirements of our users with the traditional business model. Therefore, China Telecom has made some innovation trail to combine these new technologies in some broadband service. So we have divided new technologies capabilities into 4 categories in our trail, including the connectivity capability, cloud capability, video capability, and the security capability. In terms of connectivity, we encapsulate the traditional network function such as broadband access, multi-node network, and mobile or satellite access. In terms of cloud capability, we have cloud storage, cloud Wi-Fi qualification management, and computing network, and cloud UI or say cloud desktop. So the next function is the video capability, including live streaming with multicast, ultra high quality video, VR, AR, and video monitor, and so on. And the last capability is security capability, including online safe, DDoS, attack protecting, online virus scanning, and so on. All of these 4 capabilities will be made available to our partners through standardized schemes such as cloud resource rating, capability invocation, platform access, and application stores. I've listed some typical collaborative applications on the top left, such as AI, such as cloud meeting, cloud OA, and so on. All of these cloud network integrated service in not only for the common users, but we also optimize for 3 types of users. The first type is smart home scenarios. Through cloud broadband, the terminal of the smart home, the capability of the smart home terminal can be enhanced. For example, the decoding algorithm of the set-top box is enhanced, or the storage capability can be expanded for the video camera. In addition, the network performance also will be improved. We provide a higher bandwidth, low latency service by put cloud resources embedded to the edge of our network. The second, we focus on the small enterprises. The key requirements of the small enterprises is to reduce their daily costs or their innovation cost. With the cloud network integrated service, we can provide them with an integrated solution of cloud resources and the bandwidth access, which effectively reduce the IT cost of the small enterprises. So this is the second scenarios. The last scenarios is the industry application. We tried with the cloud network, we can provide higher reliability, data privacy, security protection, and just like such security services for them. And this is the key requirements of the industrial subscribers. So in the early stage of cloud network convergence, there are many new features will be treated as value-added services for the traditional network service. But with the continuous emergence of the new services, we find the cloud network convergence can bring us a new business model so as to get rid of the traditional network pipeline business model. So this slide gives us the logical architecture of future cloud network in China Telecom's angle. So cloud nodes will be embedded in the network and connected together by SRv6 or computing networking technologies. Different access solutions include optical, mobile, Wi-Fi, or other, just like the satellite, connect our users directly to the cloud nodes. So IT and CT technologies will be converged in the cloud node itself to provide the more efficiency and the low-cost solutions. And some new technologies, such as integrated environment sensing and mobile communication, will emerge to take advantages of the wide coverage of the communication networks to provide the entirely new services. So we believe that multi-dimensional convergence network based on the cloud network convergence, including fixed mobile, multi-access connection, IT and CT convergence, just like environment sensing and the communication convergence will become the trend of the future architecture development. So all of this is the current practice of China Telecom. So thank you for listening. This is my session. Okay, thank you. Hi, Maggot.
Hello, good afternoon, everyone. Good morning, good afternoon. This is Maggot Tawfiq, the specialist in the access business, the access strategy and access director in Telecom Egypt. Let's us go directly to the presentation. Today, as all the operators start since maybe 8 or 9 years back to change from the copper to fiber, there was 3 questions in mind. How to increase the bandwidth day by day, how to generate a new revenue, and how this is to retain the cost. As all of us knows, every day comes new applications, comes new features. Now the Academy online is running, the Google Earth. We can say now around 538 million people is running on the FTTH. So day by day, and the application goes more, we need more bandwidth with the 2 conditions, and the cost and the revenue. As we know, all of us, when we start the implementation of the FTTH, the parameters of the implementation, it contain the active part, the passive part, the ODN. After all these years running of the FTTH, we came down from the $650 per customer until we reach $400 now as average cost for the the FTTH GPON. And we can see we did not stop at the 1G GPON. No, we go more for the 10G. And by these days, the 10G GPON goes day by day more. So we can see here from the graph, it's we reach already 4.42 million on the 10G GPON. And since we have the infrastructure, the ODN, the fiber, and all this, so the increase of the bandwidth, increase of the requirement of the bandwidth is still going more and more to reach the 10G faster and faster, as we see from 2016 up to 2022. So now, where we are going? Are we going to stay on the 10G, or are we going to go more for the 50G? All of us know now more than 289 countries already started to test, and 30 of them launched already the 50G. So in these days, with combination between the FTTH and the digital transformation, so we expect the 50G PON to move faster and faster to maybe to exceed the 10G PON. Most of the operator and countries are moving now to the 50G PON to combine the service, the triple play service, with enterprise services, with wholesale services, and with digital transformation. Going sure, el cost will go more and more since we built already our ODN and passive network. So the cost will go more and more. Maybe we expect $300 per link. And as we see from 2018 up to 2022, we reached 27K shipment forecast for the ONT GPON. That's mean the 50G PON is on, yes, is on. And we are going more country per country, and to go for the 50G PON. And already the technology, it can give us the all categories, 1G PON and 10G PON and 50G PON. Even we can use all of them at the same time. The technology allow us to use the GPON and the 10G PON and the 50G PON at the same time, with only change the SCP. So we are going to the 50G PON, yes. We are going to move more, yes. The needs coming up, yes. The cost is going down, yes. So this is what I want to say for my presentation. Thank you. Mr. Aldo, please.
Thank you very much. Thank you very much, Mr. Majid. Sorry, my network was disconnected. Apologies, everyone. So I would like to invite Mr. Aldo, as an industrial manager for Datacom working in Huawei, so talk about his understanding for Datacom network industry from his perspective. So over to Mr. Aldo, please. Hi, Aldo, you hear me?
Hello? Yes, apologies. Probably I pressed the wrong button. Can you hear me? Hello?
Yeah, we can hear you now. Please go ahead. I think you was muted there.
Okay.
It's okay, fine. Please start.
Thank you. Okay. So, definitely we are in front of a leap in what we know till now as the current operator network and services with manual O&M mainly, static services where you need to configure, taking a lot of time, the proper connectivity that, let's say, are broadband, but not, let's say, of high speed. What we are moving into is definitely a network with a high efficiency. So autonomous network of level 4, according to definition of TM Forum and ETSI. And I can say we had the opportunity to run some tests with the ANTC in Huawei recently, and their result is for 3.8. So we are already moving down the path of ADN. Then elastic and flexible, meaning that not only the network is easy to maintain and manage as an infrastructure, but also the service end-to-end life cycle is flexible to match the cloud life cycle, where compute resources are on demand and flexible to handle, to request, to release, and definitely an upgrade in broadband, really providing each user, each terminal, a very huge connectivity for services, providing the, let's say, ultimate experience, as we mentioned down in the slide, for, let's say, make day eyes 3D with, let's say, high quality 3D video that also can help as augmented reality in work and also in vertical industry to evolve towards a completely new way of working. So what we can see is definitely an elastic end-to-end connectivity from the end user up to the cloud, up to the data center. Okay. So starting from the access, we can say that from home, from cellular, from industry, but also from campus, dedicated connectivity have to reach out. Definitely the compute and the HPC compute ready for AI training model and to support huge computing power needed by also each vertical that will use AI more and more. So here the 800 giga Ethernet will become a reality in the coming future to support all the needed connectivity within HPC system, granting high throughput and to support all the power of the CPU and GPU that elaborate the AI computing. Also, a converged DCN, leveraging on this technology, can be used both for storage and service connectivity without any dedicated and duplication in this connectivity structure. Definitely a major role is played also by the backbone that will have to properly handle the end-to-end connectivity using a single protocol from the end user to the application that is leveraged on IPv6 and SRv6 is definitely a protocol able to simplify and substitute a lot of different protocols used today in the chain that connect the end user to to the service. So here we see something that really goes end-to-end, reaching the application through the backbone that respect the proper priority and do the proper steering. So also simplifying the elephant flow handling and load balancing that currently is a struggle in data center and in service delivery. Of course, there could be also regional data center within the network and application integration with the service function chain that integrate network and application more and more. We know that with the SAR header, also application can be addressed and properly added in a service function chain. On top of all these, a digital map, so a copy of the end-to-end network, keeping track of all the connectivity, having a forecast on any possible SLA breach for each connectivity, and proactive action to preserve the SLA of this end-to-end connectivity, as well as simulating all the changes in this digital map before to apply them in the real network. So trying to avoid all the not desired effect on the ongoing service of the network. So all these reflect in why Huawei is joining the WBBA work. There are the 4 working group that are all, let's say, properly addressing the evolution of the network in several aspects, and we feel the new work item network evolution for 5.56G era that just started in working group 5 on architecture could be, let's say, addressing all the questions that we are having today, and definitely you are welcome also to contribute to understand and point out we are going, what's the future need, because of course also as Huawei we are very careful in listening and trying to be ready for any need in the future. So it's a good opportunity to collect, discuss, and define this path. Yeah, so here just to point out that of course IEEE, IETF, and other standardization body bring new technology and functionalities to life, and definitely WBBA could, let's say, define the scenario and steer and define the guideline and define where really and how those technology needs to be used in a profitable way in the evolution of the network. So definitely is let's say is something that gives the WBBA we see a good place in the industry. Thanks a lot.
Thank you, Mr. Eldo, for presenting the overall infrastructure for the IP network. And I agree with you that the bandwidth upgradation on access metro core is the next step for enduring IP networks for the cloud network convergence. So now we are moving to the next section, and that's about the panel discussion among all the speakers. We have some of the questions we already listed here, and then we can pick some questions from the question widgets from the audience as well. So my first question to the speakers are, what are the advantages of cloud network convergence compared with traditional network in terms of the information infrastructure? So if Mr. Chen, if you would like to answer on this question with a brief comment.
Yes, yes. Thanks, Sam. This question is an interesting question because different people may have different opinions or ideas for this question. So from China Telecom's views, we think there are at least some benefits cloud network convergence can bring us. First of all, cloud network convergence will greatly enhance the capability of our network and will promote the new business models because they add more element to our traditional network. So, of course, it will improve our performance of the network itself. Secondly, it will extremely improve the efficiency of the information infrastructure with the collaboration of cloud resources and networks. And I think the third is cloud network convergence can make the architecture and the layout of cloud resources and network more reasonable, and the comprehensive investment of cloud and the network are reduced if the scale of the cloud resources and the network bandwidth or other network performance can match. This is very important to reduce the cost or save the cost of the infrastructure network, such as our metro network, access network, and our cloud network. Yes, this is all my opinions about this question.
Okay. No, that's very clear. So what do you think about the significance of IP and optical convergence? Why they need IP and optical converge together for this fixed mobile convergence?
Yeah, this question is one of our questions based to the network evolution. As we all know, there are many network function virtualization scheme in the cloud network. The performance and the cost is an important problem preventing the development of NFV. If we could offload the common traffic forwarding to optical network equipment, I think it would greatly improve the performance of NFV solutions. It also makes the networks more flexible and save the resource for the whole network and the cloud resources. So I think this is why we need IP and optical cooperation to improve the performance of the network convergence. Yes, this is all. Thanks.
Okay, thanks. No, that really makes sense for me as well, that without the converge of IP and optical, it's difficult to get unified platform for one interconnection to multi-clouds, if that makes sense. My second question, second topic I want to discuss with Mr. Majid. If you can discuss something about that, what are the best recommended scenarios for FTTH migration from copper or the old networks? And on top of it, which technology you would prefer, like simple GPON or XGS-PON? So what is the better choice for service providers?
Thank you, Mr. Samer. The most important thing of the FTTH technology is the flexibility. Flexibility of the FTTH can let you go through the SG-PON and the XSG-PON and even the 50G-PON on the same hardware, just changing the SFP. So for future-wise, if you are looking to the future and you start to implement the FTTH, my opinion that you go for the what we call it any bone or flex bone or whatever, then according to the need, you can start moving from the GPON to the 10 GPON or to the 50 GPON in very easy way. At the same time, if you are going to migrate from the copper and fiber, there is very important thing, which is the migration should not affect the customers. So you need logical and data for the ODN fiber you are going to do, and just you can use the different scenario of implementing the FTTH. You can just use it at the host, at the exchange. You can use it even in outdoor solution, and at the same time you can use it as a small unit implemented in different building and connected directly to the host. So in this case, you already shorten the switch over from the copper to fiber, and you can do it just area by area with different scenario of ODN, like the traditional ODN or the facade just using on the building and so on. Thank you.
Okay, thank you very much, Mr. Majid, for sharing your thoughts on, especially on the 50G PON, because service providers are really interested to explore that technology for their home broadband networks. And I do understand that should be profitable in terms of return on investment if they are using the same ODN. I agree with that one. And because we are running out of time, but I would like to minimize the session. My last question to Mr. Aldo. Could you explain that what is the role of the cloud-based, unified cloud-based automation, especially in terms of a digital mapping for end-to-end IP and optical underlay over networks? And then how far in the standards we already reached that one? Because most of the, vendors industry, they are claiming that they are having the higher standards for multi-vendor interoperability. So what is your understanding on this one from the automation perspective?
Thank you. Thank you, Mr. Samir, for this question, and also would like to, let's say, in this question answer also to Ms. Raja that sent an interesting question on how to automatize the network end to end. So as you already point out, the digital map is at the heart of auto and slicing technology to provide customized and flexible service end to end is definitely what's needed from the market to serve the consumer new request for entertainment services and interacting services, but also all the different vertical that we saw before for unmanned industry and so on. So definitely a good IP technology to underpin automation is needed. As of today, there are really a lot of protocol to connect every single domain of the network, the access with the call and the backbone and data center and so on, all with a very complicated and difficult manual handling that is difficult also to automate. So definitely an evolution in this IP to provide flow connectivity end-to-end, enable a easy digital mapping of the network and automate the needed connectivity services. So in terms of automation, definitely there is, let's say, some closed loop, real-time closed loop, very close to each and every single equipment, to solve real-time issues. There are controller implementing automation at domain level, and of course there must be an orchestration end-to-end to include all those new possibility offered by the connectivity automation with the cloud automation, really to create an end-to-end service from compute resources to the needed connectivity, all tailored end-to-end and well orchestrated by those level of automation. So this is.
And sorry, Aldo, I just have one more question in the audience from the audience. That is there any recommendation for optical cable management from the automation perspective? In my understanding, there is no such software. It should be controller, right? And every vendor should follow the open config and the YAML model. So what is your recommendation for the optical management?
Okay, so definitely is let's say I'm more on the IP side of the technology. What I can say, there are protocol like FlexE that enable to create hard slicing at also optical level, we can say, so that we can preserve certain services at a defined bandwidth and not to be interfered with other services. And let's say the interaction also with the IP level from that point of view could be very, very close. So with the services providing what is normally addressed and called as soft slicing on top of FlexE. So that's the chain, the ring of the chain that I see from optical to IP to melt them together.
You there, Mr. Aldo, or is all done, right?
Yeah, can you hear me?
Okay, yeah, I can hear you. I think there was some glitch in the network on your side. Okay, thank you very much, Mr. Aldo, for answering on the digital mapping and end-to-end network automation, including IP and optical. So we already asked the questions from the audience panel as well. So now we are moving to the last part, that is the conclusion from my side. So being an analyst and the key writer for the white paper, I would like to summarize this webinar into 5 important messages. The cloud network convergence is the trend and is an inevitable trend for moving towards a digital era. And this digital era is based on future emerging services for industrial metaverse or the consumer metaverse at home. So for making more revenue from the B2B industry, service provider must empower their enterprise and vertical customers, bringing them one hop, simplified access to multi-cloud interconnection. So simply one underlay network, IP plus optical, and unified cloud platform. So cloud and network can go hand in hand together. That's one message. Second, end-to-end network should be having a deterministic latencies. We don't need only connectivity, we need an intelligent network, and intelligent network can only ensures deterministic capabilities. That's my research and that's my conclusion on the network cloud convergence as well. Third, secure cloud edge device collaboration. So we don't need only network, but we need a security on the cloud and edge collaborations as well. Because the transport network is just bypassing, or not bypassing, I can say is bridging the traffic from the wireless towards the edge, towards the core. And then in the IoT era, how we can do the secure collaborations. Then is a heterogeneous consumer industrial IoT access. I already talked a lot in my session, because that's the motivation for network cloud convergence. And last but not the least is this, how we can intelligently connected network for consumer metaverse. So XR, VR clouds, gaming, all that stuff that need high bandwidth, high throughput, low latencies. So how we can cater that B2C part of the service providers. So it's not, I can say in one sentence, is not an easy job to make a cloud network convergence, but it's a long journey. And all service providers, as my recommendation, need to plan 5 or 6 years target network modernization for IP and optical with the increment of the bandwidth on the access, metro, and core. Similarly, on the optical side, and then XGS-PON capabilities on the home broadband, consumer broadband. And top of it is a digital map, sort of a centralized cloud automation that should be open, agile for traffic engineering. That actually drives the digital economy and connectivity into the intelligent world of digitalization. So that's all from the webinar today, and that's the conclusion and key takeaways. At the end, I would like to thank all my seasoned speakers, Mr. Majid, Aldo, Chen from China, for your contribution and your time in speaking in this session. Though we had some of problem on the network on my side as well, and then some speakers on, but that's the beauty, and that's the reason we need a cloud network convergence. By the way, we need a solid network to connect end to end. And then feel free to download the white paper that I wrote on the World Broadband Association is already launched there. And if you have any questions, you can feel free to send me or my seasoned panelists, and we are more than happy to answer all the questions. Once again, thank you very much, and have a good day. Thank you.
Okay, thank you, Sammy.
Thank you all. Thank you.